Turn to this page in your packet. It should say Unit 1.3 Angle Measure Notes. Your learning target for today is I can classify, name, and solve for missing measures of angles. Please write that where it says learning target. Okay, next we're going to look at what are angles. Well, in order to define angles, we must first define rays. So write ray in your notes. And a ray is part of a line that has an endpoint at one end and goes on indefinitely on the other side. So this is an example of a ray right here. So you see it has an endpoint at point B, and then it goes on indefinitely on the other point because it shows an arrow. That means it just keeps going on. This right here is another example of a ray. So this would be ray BC, and this is ray BA. So let's go ahead and write that definition. Okay, part of a line that has an endpoint at one end and goes on indefinitely on the other side. Okay, so it looks like this. And if you want to denote an angle somewhere, then you would name an angle like this. So this, for example, right here is not angle. This right here is ray BA, and we would write that this way, BA, and we put a line at the top with an arrow, and that means ray BA. Okay, next, what's an angle? Well, an angle, go ahead and write angle in your notes. An angle is formed by two non-collinear rays that have a common endpoint called a vertex. So, this is one ray, this is ray BA, this is ray BC. They have a common endpoint called point B, and this is the vertex. This right here is an angle. Okay? So, formed by two non-collinear rays that have a common endpoint called a vertex. So if I were to ask you what do you call the endpoint of two rays when they merge, that would be a vertex, right? Okay, how do we name angles? Well, this angle right here has 4 different names. It's an angle ABC, and we would write that like this, angle ABC. We can also name it angle CBA. Just follow this, CBA. You write angle and then CBA. And then we can also name it by its vertex. So it would just be angle B. Angle B. And then last we can name it angle 2 because it has that number 2 there. But you might wonder, well, it's got that 2 there. Does that mean it's 2 degrees? And the answer to that would be no, because there's no degree sign there. If you would see degrees here with that degree sign, that little bubble here, then yeah, it might be. But this time it's not 2 degrees, it's just angle 2. So we would write angle 2. Okay, so those are our 4 names for that angle. Next, we'll look at what are interior and exterior points. Interior points are any points inside whatever angle I'm looking at. Okay, so if I asked you what are the interior points for angle A, B, C, the interior points would be right here. Now, is point A and point C, are those interior points? No. Those points are neither interior nor exterior. These are points that are on the line. Okay, you can see that they're on this line right here, and they're on this line right here. So they're not interior or exterior. So interior points for angle A, B, C are points G and D. Now, exterior points are any points that are outside of the angle. Exterior points for angle A, B, C are points F and H. And then you might wonder, well, what about point E? Is that an interior or an exterior point? Well, point E, again, is neither, because even though the line that you see drawn isn't actually touching it, this line has an arrow, which means it extends indefinitely, and eventually that line, if you continue it on, you can see with my pencil right here, this line would eventually hit that point. So this point E is not interior or exterior, it's a point that's on the line. Next, we're going to measure a few angles. So first I'm going to want you to measure this angle, angle ABC. You're going to take your protractor and you're going to line it up with the ray that's on the bottom. Okay, so once that's lined up with the ray, and then you make sure that open circle is on the vertex. You see that this open circle is on vertex B. Okay, and then I'm going to put a white piece of paper under here so that I can see the numbers better. If you need to do that, do it as well. Okay, and then what I'm going to do is either I'm going to take a pencil or another piece of paper, and I'm going to go ahead and line it up with that other arrow. Okay, and then for this angle, if you can see right here, this should be around 133 degrees. So I'm going to write in here 133 degrees. Okay, so that angle is 133 degrees. I want you to measure each one of these angles as well. So this angle right here appears to be right around 30 degrees. So you're going to write 30 degrees in here. This angle right here, I'm lining it up again and lining it up again. This angle appears to be 90 degrees. So for 90 degree angles, instead of writing 90 degrees, I put a little square inside of that to show 90. And then this angle appears to be, let's see, it appears to be 135 degrees because we got 130 and then we go right to this little tick mark right there to show that. So it's 135. So I want all of you guys to get practice measuring your angles using your protractors. Okay, next we're going to classify these angles. This is an acute angle. What does acute mean? Acute means an angle that measures between 0 and 90 degrees. So it's bigger than 0 degrees and it's less than 90 degrees. So I'm going to put 0, it's bigger than 0, And then I'm going to put M to show measure of an angle. So this is angle A. Measure of angle A is bigger than 0 and less than 90. Okay? And then I'm going to put degrees. Okay. A right angle. A right angle is an angle that measures exactly 90 degrees. So I'm going to put measure of angle B. This is not a greater or less than sign. It's an angle sign right there in that case. Equals 90 degrees. A right angle is an angle that measures exactly 90 degrees. And an obtuse angle is an angle that is bigger than 90 degrees and less than 180 degrees. So I'm going to put my 90 degrees. This angle has to be bigger than 90. So measure of angle C is bigger than 90 and less than 180 degrees. Okay, so next what we're going to do is we're going to go ahead and add some angles. A part of one angle plus a part of another angle can equal this whole angle right here. So angle GHI equals angle GHZ plus angle ZHI. So right here it says measure of angle ZHI, that's this one right here, is 55 degrees. And it says measure of angle GHI, so it's this whole thing, the big thing, is 165 degrees. Find GHZ, measure of angle GHZ. So that's this right here. So we have the whole is 165, and we have a part is 55, so we just subtract this part to find this missing piece right here. So 165 minus 55 equals 110 degrees. So measure of angle GHZ is equal to 110 degrees. Alright, that's how you do that part. Now this next part looks similar, but now instead of numbers it's got variables. It's got some x's. Okay? And it says find IJL, measure of angle IJL. So that's this one that they want us to find. And it says if measure of angle IJL is x plus 65. And measure of angle LJK, that's this one, is x plus 107. And then measure of angle IJK, that's IJK, this whole part, the whole thing right here, is 158 degrees. So part plus part equals 158 degrees. So x plus 65 plus x plus 107 equals 158 degrees. X plus x equals 2x, and 65 plus 107, that's 172. So then I got 2x plus 172 equals 158. How do I solve for x? Well, I have to remove all the things that I see with x. First, I start with what's farthest away from x. Farthest away from x on the same equal sign, side of the equal sign, is this plus 172. To remove it, I just have to do the opposite of what is happening. So the opposite of plus 172 is minus 172, and I have to do that to both sides. So 172, subtract that, Subtract the same from the other side. Okay. And we get 2x, that carries through. This cancels out, because 172 minus 172 equals, ooh, we get a negative number. Yep, so this will be equal to negative 14. Okay, next, x is still not alone. How do we get x alone? Well, we have x multiplied by 2. To do the opposite, we divide by 2, and we have to do that to both sides. So 2 divided by 2, that gives me 1, so I just get x. 14 divided by 2, that gives me negative 7. Okay, next what I'm going to do is, I got to see, is this going to be, am I done? X equals negative 7? Well, no. I look back, what was my question? My question was find the measure of angle IJK. Well, angle IJK is this one right here, and it's x plus 65. So I write down x plus 65, and I get negative 7 plus 65, and then that will give me 58. So 58 degrees equals measure of angle IJL. Does that answer my question? Find that? Yes. Next, we're going to discuss angle bisector. Well, an angle bisector is a ray that cuts an angle in half. Okay, so let's go ahead and write our definition. We'll write a ray that divides an angle into two congruent and equal angles. So, oops, I already started wrong. Alright, a ray that divides an angle into two congruent and equal angles. What does that actually mean? Alright, well, we remember congruent means that the shapes have the same measure. Okay, so this ray DG, is a bisector of angle CDE. That means that this angle right here, angle CDG, is the same measure as angle GDF. So let's go ahead and write that angle CDG is congruent to angle FDG. CDG and FDG. Okay? And congruent is just this equal sign with this squiggly on top. Okay? So those are the angles total. If I want to say the measure of an angle, that's a number. It's not going to be congruent, it's just going to be equal. So that means measure of angle CDG is equal to measure of angle FDG. The difference between the equal and the congruent is that congruent talks about the shape in general, and the measure is an it's a number. Okay. So, and then measure of angle CDG is 1/2 of CDF. So CDG right here, and CDF is this big one right here. So this one is the bisector, so it cuts that in half. So measure of angle CDG equals 1/2 measure of angle CDF. And then the same thing will be true for this other side as well. So measure of angle FDG equals 1/2 measure of angle CDF. Okay, so next what we're going to do is we're going to solve some equations based on this idea that we have angle bisectors. It says that we're going to use this image right here, and that FA and FE are opposite rays. So FA and FE, opposite rays. You can see it's a straight line, so they make a straight line. FB, which is FB right here, bisects AFC. That means that this angle right here is equal to this angle right here. And FD, which is right here, bisects CFE. That means this angle right here is equal to this angle right here. They're congruent. Okay? And then it says that if measure of angle AFB is equal to 3x plus 4, so AFB, this one is 3x plus 4, and measure of angle BFC is equal to 46, find x and measure of angle AFC. AFC is the big one. So we have to have two answers because it's asking two questions. Okay, so to do this, I'm going to have to consider that this right here equals this right here, because these are two equal halves of this big one. Okay, so I'm going to write that down. 3x plus 4 is equal to 46. I'm going to try to solve for x, and to do that I need to remove whatever's with x. So I have to do the opposite of what's happening here. So subtract 4, and I have to do that to both sides. 3x is equal to 42. And then I have 3 times x equals 42, so I have to do divide by 3. Divide by 3, because that's the opposite of 3 times x is dividing. So this cancels out to 1, and then I get x equals 14. That's one of my answers, 14. And then it also asks for the measure of angle AFC. Well, we know that this is the bisector, and half of measure AFC is 46, so 46 times 2 should give me the whole big angle right here. Part plus part equals whole. This is the whole that I'm asking about. So measure of angle AFC is equal to 46 times 2, which is equal to 92. So 92 degrees is equal to measure AFC. Okay. Okay, so for this next question, it's asking measure of angle CFE, that's this big one, is 2x plus 10. Okay, so 2x plus 10 is the big one. And DFE is 6x. So DFE is this one right here, and that's 6x. And then it wants us to find CFD. So that's this right here. I'm going to put a question mark. Okay. Now, I remember that FD was a bisector of CFE, which means that this right here, our question mark angle, is congruent to this right here, our 6x. Okay? So once we solve for x, then 6x should be the same as our question mark angle that we're trying to solve for. So first let's solve for x. We have this big one, and then it's bisected over here, so this has to be half of this big one, or 2 times this is equal to the big one. So 2 times 6x is equal to 2x plus 10. So 12x is equal to 2x plus 10. The problem is I have x's on both sides of the equal sign. I really want my x's to be on one side of the equal sign and my numbers without the x's on another side of the equal sign. So we have a positive 2x, and we want to remove that from that side of the equal sign. So to remove it, I do the opposite of what's happening here. So positive, the opposite would be subtracting it. So subtract 2x from this side and subtract 2x from this side. So I get 10x, 12 minus 2 is 10, and this 2x minus 2x cancels out, and then I have to carry down that to 10. Okay, so 10x equals 10. We still have that 10 in front of the x, so 10 multiplied by x. Doing the opposite would be x dividing by 10. Alright, so I'm going to divide by 10, divide by 10. That goes to 1. This also goes to 1, so x equals 1. Is that our final answer? Are we done? No, it also asked us for measure of angle CFD. But earlier we said that, not the CFD, yeah, CFD. But earlier we said that this angle right here is the same as this angle right here, because the big one was bisected into two equal halves. So 6x is that measure of that angle, because that's that angle. So measure of angle CFD equals 6x. Are we done? No, we can actually simplify this more because we know what x is. We know that x is 1. We just substitute that 1 into that x, which is equal to 6 times 1, which is equal to 6. Okay, so measure of angle CFD is 6.